Okay, so 1.4, you should have your notes out. We are talking about powers of 10 and other numbers. This is our big topic. Okay, so we have to define a few words. Look and see if you've got these defined. So when we're writing something as exponential, it's 3 to the power of 4. It's a little up. Yes.
Oh,
Go ahead.
You said, no, I thought you were saying like we need to find these. So.
Oh, no, I'm going to talk about these. Okay, so when you write something 3 to the 4, this is a special notation. What it really means is repeated multiplication. So this means take the base, this is the base number, and this is how many times you multiply, or how many numbers you multiply. So, multiply, I can't spell. So this is 3 times 3 times 3 times 3. Notice the number is this. The base is what we multiply. Yes?
By itself.
By itself 4 times. This little 4 tells you I'm going to have 4 to multiply, or 4 threes to multiply. So that's what it really means. And when we look at the 4 is actually giving 2 names. It can be called the power. We read it 3 to the 4th power. That's one way of reading it, 3 to the 4th power. Or it can be called an exponent. Okay, so usually we read it as this, as 3 to the 4th power. Okay, remember that is one of those numbers that's a sequence thing. And so we're really saying, okay, you've got 3 times or 4 threes that you're multiplying. Okay. A lot of times, if I'm just saying, what is this? When I just say, what is this? This is the base, and this is the exponent. So identifying the parts, this is what we're doing here. We're identifying the parts of this. This is how I read it. This is the parts of it. So this is the 2 parts of an exponent. We have the base, which is that bottom number. It's the number you repeatedly multiply. And then we have the exponent. Okay, so those are some terms. You'll hear me, we'll ask you to read it properly. We'll also look at, okay, what does that actually mean? What's the base? What's the exponent? Okay, so they had some important powers to know. Those were 2 to the 1st power, 2 to the 2nd power. So there was a chart there that you could write down. Then we looked at powers of 10. Okay, why would I want to look at powers of 10? Does anybody have any idea why we'd want to have powers of 10? Yes?
It would show that you just keep like adding numbers.
It kind of does that. Okay, I want you to think about what we do. So when we're looking, so that's a quick way of doing that, but when we're looking at powers of 10, we go like this: 10 to the 1st, 10 to the 2nd, 10 to the 3rd, 10 to the 4th, 10 to the 5th. Those are powers, right? Okay, here's it's to the 1st power. Jonathan, what does that mean? What would that equal?
10 to the 1st power?
Yeah.
10?
It equals 10 because it's 10 written once. There's nothing to multiply by it. It says write it once and multiply. Well, 10 to the 1 just means I have 10. Okay? 10 to the 2 means what, Hayden?
100.
It's 100. How'd you get that?
Because you're timing itself.
10 times 10. Notice the base is 10. That's what we're multiplying. How many times are we writing it down? Twice, and then we're going to multiply. So 10 times 10, which is 100. Okay, what's 10 to the third, Gavin?
1,000.
It's 1,000. It's 10 times 10 times 10, because notice the base is 10. This time it's 3 times, and it's 1,000. Okay, what is 10 to the fourth?
10,000.
10,000. Okay, and then 10 to the fifth is how much?
100,000.
100,000. Do you recognize any of these words? If I look at the numbers 10, 100, 1,000, 10,000s, 100,000s, what is that referring to? Yes.
Okay.
Mhm.
It adds a 0 every single time.
Yes, it does. That does true. Okay. Have you seen those when we are looking at numbers at any point? Have you seen the words 100 or 100, 10,000, 10,000, 100,000? Let's look back. Let's look at this number. Oh, we're not going up there yet. What place is that 4 in? Oh, let's go backwards. We don't want to start there. Let's start here. What place is the 1 in? Yeah.
Thousands.
Is it? What's the first number? Let's go back to our chart real quickly that you guys were using. On page 20, what place value is that 1 in? It's in what place? Yes. The ones place. We don't have a 1 on there. We'll talk about that in a minute. Okay. What is the 2 in?
10 or 8.
The tens place. Oh, that's that one. What is the next one in? Yes. The hundreds place. Oh, that's interesting. The 100 is right there. What place is the 7 in? Yes. The thousands place. So that we know it's the thousands. These are actually the place values of our numbers. Okay? The powers of 10 are actually the place values for our number system. We are called a base 10 number system. That means the base is 10. And every time you go up to the next place value, it's multiplied by 10. I don't know if you did it when you were a little kid, but you might do the groupings and you would say, if I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I get 10, I don't write I put a 0 in the ones place and in the tens place, because now I group all these together and move them over here, and there's just one group of 10. So we have this group of 10. You can't see 10 there because I didn't draw 10. Okay. Now I have one group of 10. That's why we write the number 10 as 10. When you get to above 9, we go up to the next value. And that's because we're going basically up from 0 to 9, which is 10 places, 10 place values that can be used in the ones place. Then we only go from, our digits only range from 0 to 9 in this one. When we get to the 10th one, we group them together and we put them as 100. Because now we have 100. If I have 10 groups of 10, right? Think about 10 groups of 10. That's 100 of them. So once I get 10 groups of 10, I move it into the hundreds group. Okay, does that make sense? That kind of makes sense. That's how we are based in our system, number system. So the powers of 10 are very important. So you can learn to write this out actually as an expression with powers of 10. You can actually write it out to see what it means when we're looking at this, this is really 4 is in the thousands place or 100,000, so it'd be 4 times 100,000 is what we really have. 5 is in the 10,000s place, so that's what we really have is 5 times 10,000. We have 7 times 1,000. That's what we really have. We have 6 times 100. We have 2 times 10, and we have 1 times the ones. If I multiplied these out, it would give me 400,000, 457,000, right? 621. 600, there's your 100. 20, that means tens. 1. Okay, so in our power system, that's what the place value actually stands for. This number right here actually represents 4 groups of 100,000. That's what that represents. And so powers of 10 are very important for us to understand what's going on and for us to understand how to write big numbers and small numbers. We're going to learn how to write really big numbers and really small numbers. Okay, and that's part of this. Okay. We have a few more minutes. And so what happens, exactly what you were saying, Hayden, every time I multiply a number by a power of 10, it moves the decimal 1 place. Okay, so why say that? Or it adds an extra 0. So if I have the number 3 and I multiply it by 10 to the 5th, well, if we go back here, I've written it off, but 10 to the 5th is one where I have written 5 zeros, okay? You're going to work on this tomorrow to see what those equal. Okay, you'll notice that the 5 zeros is 10 to the 5th power, okay? So then I can write this out by just saying 3, and I know that's 5 zeros behind it. 1, 2, 3, 4, 5. It's 300,000. So we can make that quickly. We can multiply by tens or powers of tens very quickly. Okay. If I have the number 246 times 10 to the 3rd, I'm going to add 3 zeros. Because it's 246, 0, 0, 0. It's adding extra decimals at the end. Okay. Now, if I had 2.46 times 10 to the 3rd, that's a little different. Because the first time I'm multiplying by 10, it will bring me to 24. The second time I multiply 10, it will give me 246. And the third time I multiply by 10 will give me 2,460. 10 to the 3 is still 1,000, right? So it is 2.46 times 1,000. But we have, when I multiply the first 10, it moves that over and we get 24. Because 2.4 times 10 is now 24. 2.46 times 100 is now 246. And then that last 0 becomes a 0. It's the only one I put on is the 0 there. So as I multiply, it actually moves my decimal to the right. Okay, it moves my decimal to the right. Because if you really think about it, where's my decimal here? It's right there. How far did I move it? I moved it 3 places to the right, so that's why I got the 0. Okay, so multiplying by a power of 10 moves your decimal that many places to the right. Okay, makes your number bigger. It should be because you're multiplying by powers of 10. Okay, so it should be bigger. Okay, does that kind of make sense? No, yes, no, yes, okay. So tomorrow, hopefully you will hear me better than last week when we did that. Hopefully you will see me, but we're going to work on some activities with this, with the powers of 10. We're going to do some activities. So you can really kind of understand that. I like you to be able to understand why our decimal system is based on tens, or where our number system is based on tens. If it was based on twos, it would be very confusing. Let me just tell you.